Hey guys, today we're going to do some data visualizations. So up until now we learned how to inspect the data, how to prepare it, we learned to apply different functions, and now right before going into modeling we should learn how to visualize it. We should aim on finding the best and most optimal way to present our data in graphical manners. So last time you played with some histograms, but now we're going to use Seaborn. It's a different library based on Matplotlib that can give us many options of visualizations, can give us great, really great options for visualizations. So first, like always, we're going to import pandas, but that's not enough, right? Because we're using Seaborn. So we should also import Seaborn and all the other libraries that are associated with it. Since we're going to operate some mathematical, we're going to do some mathematical operations and statistical operations for perfect visualizations, we should also load the relevant libraries for that. And of course, the Matplotlib libraries, that there are many of them, and we should use whatever is relevant for our visualizations. So in this case, I used free, but yeah, you can use whichever that's relevant for your visualizations. Now, for today's tutorial, at least for the beginning, we're going to use the campaigns dataset which is available on our Dropbox. You used it before in the first week or the second week, and now we're going to inspect it again right before applying our visualizations. So first, let's see which columns we have. So in the dataset we know that we have a website column that we can see. It has different types of websites. Then campaign, it's a number of a campaign. We have clicks, the number of clicks, and sales. Going next, we see that basically website is a categorical data. It's a noun. So when one of our main variables contains categorical data, we should aim at finding the clearest way to visualize it without overloading the graphical interpretation with irrelevant data and figures. Visualizations of categorical data can be highly structured or providing a more abstract representations of the observations, distributions, and can even visualize statistical estimations to show a measures of central tendency and confidence interval. So we're going to see next how we're going to do that, but let's start with some simple categorical data visualizations. So obviously the simplest one of all would be the bar chart. In this case, we can see in our bar chart that the count of each of the categories is the same. There is 12 pages of New York Times, 12 pages of Twitter, 12 pages of YouTube, and etc. This simple bar chart, as I said, it just shows the count, and we can define the x's, the data, and the color. So at the x, I can define what would be the categorical data that we're gonna visualize. At the data, obviously, we're gonna refer to our data set. At the palette, we're gonna choose the color. If we want to transform it, we can also put the website column at the y's and not only at the x's. Now, going next, we can see that with scatter plots, which is this kind of graph, we can visual categorical data and numeric values. In this example, we used the website's categories and presented it over the distribution of clicks per website category. Using the jitter command, we can adjust the position of the plots so that they will not overlap. So if I'll write false, it's going to look something like that. If I want to keep it more, I'd say realistic, or it will look more natural, I'm going to use the true, and then they will not overlap apparently. So Well, in these visualizations, we're quite limited because we have 1, 2, 3, 4, 5, 6 categories. And it can be a little bit overloaded. As we said, when presenting categorical data, we should really keep it structured. So what we're going to do next is categorize those websites into categories. We're going to apply a word list any present function that's going to categorize the websites to news, social media, and video, where New York Times and USA Today are news, Facebook and Twitter are social media, and YouTube and Vimeo are videos. I'm going to apply another function to finish this categorization. And then, once the websites are categorized in groups, we can add another variable to our visualization. We could also do that without categorizing the websites. But as I said, data visualizations should be readable. Hence, if we should really consider the aesthetics and the structure of our data. If we'll add another variable to the former visualization we had, it would be too messy. In this example, we included the campaign number, comparing the frequency of each website category, news, social media, and video, in each of the campaigns. So again, as you could see, that's a count plot. We have the x's, but now the y's are count. We don't define the y's, and however, we can define the who. So we can define the condition, the type of website. Again, we define which dataset we're referring it to, and the colors. We can also add another variable in the y's instead of the count and visualize how many clicks each category has in each of the campaigns. So exactly in this scatter plot, swarm plot, we changed the count to clicks, so we can see how many clicks are there per campaign within each category. Now let's look at some visualizations with estimations. We can use categorical visualizations to present some statistical estimations, as I said before. The next box plot demonstrates 3 quartile values of the distributions of the number of clicks each category has in each of the campaigns. So basically, each of those boxes represents the type of website within each of the campaigns, and then it stretches over the number of clicks each type of website received within each of the campaigns. Now these lines represents the quartile range from the third to the first, and those dots, actually, these are extreme values. In the following bar chart, the black lines, which are actually called error bars, represents the confidence interval. Differently from the box plot, this bar chart presents the mean number of clicks instead of a normal count. So as you could see on our y's, instead of just clicks, it says mean clicks. It's a mean number of clicks that we have per each website category per each campaign. As you can see on our x's, we have the number of campaign, and then the black line, the arrow bars, presents the confidence intervals. Now, we looked at some graphs, but sometimes it's actually better to present data in a table. So in some cases, in this case, we can use cross tables. This following table presents the number of items in each website category within each of the campaigns. So we can see that we have 5 social media pages in the second campaign, 3 news pages in the sixth campaign, and etc. We can also do it with percentages. We're going to apply the following function that basically convert our count to a percentage, or percentile to be exact, and then we get this output, saying, for example, that 12.5% of the first campaign is of videos has to do with in the first campaign, and etc. Now, Seaborn allows us to visualize statistical properties and not only categorical data. So last week you already visualized some histograms, but now let's see, when dealing with univariate data, how we can actually visualize it using Seaborn. So Seaborn visualization can present statistical estimates and distributions. In this following histogram, I outlined the distribution of the clicks in the dataset. So we have a histogram, and we also have the distribution within the variable. So we applied it on clicks, and we can see that clicks is pretty much normally distributed. Pretty much. It's a bit messy, but that's what we have. This is like appearing to be real data, so it cannot be perfect, but that's what we have. Similarly, it is also possible to plot bivariate data. The following graph represents the bivariate distribution of sales and clicks, while the side graphs present each individual variable distribution on a histogram. So we visualize sales against clicks. We're going to explore the relationship between sales and clicks, basically. In this histogram, we can see the distribution of clicks by itself, and in this histogram, we can see the distribution of sales by itself, the univariate distribution of sales and the univariate distribution of clicks. And here we can see the bivariate distribution of both, and actually can explore the relationship of them. Well, as much as it's nice, it would be better to explore it with a regression. So we can actually plot a regression line using this following command. First, we'll have to apply a numpy command. Numpy is actually it's a library for mathematical and statistical operations. And then we're going to apply the Seaborn command for the visualizations, and then we can see that we have some kind of a linear relationship, between sales and clicks, pretty much. Now, if we want to apply it on the rest of our data sets, is also possible. We're going to apply a condition. We can visualize the bivariate distribution of sales and clicks in each of the website's groups. Apply a condition that will visualize it according to each of the website's groups. So blue would be news, green would be social media, and red would be video. And then basically we can see the different distributions of all, seeing that, for example, the news have a very linear relationship, then also the green, while the red is not as much as the rest. Now, so far we had some fun with simulated data, but now we will see how visualizations look like when applied to social data. For the following examples, I scraped posts and comments from Gerard Wilder's Facebook page. We will visualize the type of topics that were discussed in the comments to the page's posts during the 6 months before the recent elections in March 2017. So, social data, first of all, obviously we're going to load the data. And if you didn't do it by now, you can go to NetViz and play with it by yourself. Look for some posts, some comments in a favorite Facebook page and scrape the data yourself. So I did it for Gerard Wilder's page, as I said, and now first and foremost we're going to load the data. Then social data can be messy and overloaded. So we should first clean and inspect the data. I categorize the data to a few topics before starting to visualize the data. So we have few groups here. We have comments that talk about Islam, topics that talk about immigration, topics that talk about the EU, topics that talk about the party PVD. For the Dutch people in class, I hope that I pronounce it correctly. And then VVD, it's a Mark Rutte party. And then finally a category about refugees. So I just illustrated something just for the sake of the example. I put some few keywords inside and ran the function and applied the function. And in the function I also included all. So whenever each of the whenever the function finds a phrase in each of the categories, it's gonna tell us that all were applied. And we have nothing, which is obviously the opposite, when none of the phrases come up. And then we have mixed, basically a mathematical operation which says that whenever we have more than one, more than two, more or equal to two of the phrases, so it's going to tell us that it was a mixed comment. So let's visualize the results, and as we can see, we're going to use the count plot, which is a normal bar chart, and we're going to put the type of comment against the count. However, most of the comments had nothing to do with each of the topics, so it is not interesting for us, right? As you with dealing with social data, we sometimes collect loads of data that are not relevant to our topic. In this case, I will focus in the following visualizations only on the comments from these categories. So before I continue, I create a new data frame, excluding the comments that have nothing to do with any of the categories. I'm going to take out all of the comments that has nothing to do with the categories. And then in line 33, I do the visualization again, and as we can see, it looks much better. And much more organized. Now, as we could see in the previous bar chart, the most frequent category were comments about Islam. So in the following example, I would like to see when was this topic discussed on a timeline. First, I should fix the dates columns so that it would fit the visualization. So, and the relevant column obviously would be comment published. If you're using post, it will be post published. So, in line 33, I'm just applying a simple command to fix the date. It's using Pandas library. And right after, I will use if I will use my current data frame, I will not be able to get an accurate visualization of this category. What I would do is creating a new data frame according to my last one, taking into consideration only the comments from this specific category. So I'm going to create a new data frame called Third Wilders Islam, which is applied. It's based on our last data frame, and then I'm going to tell I'm basically going to slice the data according to the type of comment, meaning only comments that has to do with Islam is going to be in this data frame. Now I will write the code for the visualization. So when setting the index, I should refer it to the relevant column. So as I said, in this case, it would be comment published. Then, when grouping by the time grouper, it's this function over here, I will define the frequency. So, I chose to group it by weeks with a W. Sorry for that, I wrote a Y instead. I'm going to fix it afterwards. And then you can also do it with months or days or years or hours. It's not a problem. You can also use a specific number of days, weeks, and months, like 10 days or 183 weeks, which is 6 months, or you can actually write 6 months, and etc. Now, I will define the units of analysis. So, since our new data frame includes only comments about a relevant category, the right column should be type of comment. So, that's going to be in the brackets right here. Finally, I finished the code with the function. I would like to run. So in this example, I used count because I want to see the number of comments per each point of time, in each point of time. But you can also use other functions like mean function for calculating the mean value at a particular point in time, for example. And once I define that, I can just run the plot. And as you see, we got a graph. This is 6 months before the elections. So the elections were on March 15, 2017, which is right here. So I started collecting the data in about October, give or take. And we can see when was the topic discussed the most. And we can go through the same process again, creating a timeline for the category of comments regarding the European Union. So again, we will create a new data frame with only the comments that talk about the EU, and we will define the graph. We're going to use the time grouper, the frequency, we're going to define it on weeks. Type of comment would be our unit of analysis, and then we're going to use the count function, and we're going to plot the timeline. Here we got a nicer timeline, and that's because there's not as much comments in this as in this one. In the timeline about Islam, we have up to 1,400 comments at a particular point in time. That would be in late December 2016, for example. So here we have not more than 450, I'd say, or 470, give or take. So the graph looks actually much nicer, much more organized, stretched nicely over 6 months. Now, if I would like, or we would like to create a timeline for each of the categories and present them side by side, we can use the following command. However, we should use the data frame that includes all the categories, obviously. Take into consideration that when you apply a command like this and you have as many groups as I have, it's gonna look messy. It's gonna look like this. But if you compare between genders, for example, or between 2 days of the week, so you're gonna have a nice 2 tables side by side. Now, there are many other types of visualizations and different ways and possible ways to design them. Now, I only presented few just to expose you to the idea of data visualization, so you guys will get familiar with that and will understand better how to do it yourself and what exactly each part of the code means. But you're more than encouraged to go to the Seaborn library and look it up yourself and try different kinds of visualizations. You can do really crazy stuff with it. There's a lot of things that can be explored with visualization. So please go for it and try it out and see what you find on the Seaborn library. Now, the assignments for this week. So first, using the Twitter data you collected using the DMI-TCAT, explain the distributions of 3 numerical variables in your dataset. Obviously, you'll need to visualize it and then explain what type of distribution do they have. Then find if there is a linear relationship between 2 of the variables. Now, I'm not expecting you to analyze an output or to model it somehow. There is no need for that in this point, and you definitely don't need to put your data in SPSS, to load your data in SPSS. All you need is to visualize it the way I showed you earlier, and interpretate the graph, seeing if there's a linear relationship or not. Second assignment would be categorize the tweets you collected and visualize the number of tweets per each category. And also obviously explain the output. So now you're going to work with categorized data. You're going to apply a function, you're going to categorize it and visualize it. Very simple. And then third assignment, merge your sentiment analysis results and compare the results according to the categories you created. Find the most optimal way to visualize your your categories to present the sentiment analysis results. Explain the output and report your findings. So, last assignment, you had to merge your sentiment analysis results and find a creative way to categorize it. Do it again. Find a creative way to categorize or to make some sense into your sentiment analysis results and visualize it. Now there's an optional assignment for those of you who want to challenge themselves. It's actually very simple, but you'll need to do some research to get it. Try to change the color of one of the visualizations background from light blue, like I have here, to white. So that would be all for data visualization. I hope that I made it clear enough. If not, feel free to post some issues and some questions, and I'll get back to it and answer it as soon as possible.